Hey, welcome back to Mathematics. We're doing a different style of video today. Today I'm doing a bit of a starter's guide to using Desmos and how to create designs using Desmos. This is due to my Year 11 class being given an assessment task involving making a logo using Desmos, and some of them asked for some tips in a video, so here that is. Hopefully you find some use out of this. Oh, hang on, let's just get rid of this other tab quickly. Yep, okay. All right, let's start off with just how to write in an equation. So first of all, before you start, it's a good idea to make an account with Desmos. That's my name, by the way, because then you can save graphs that you can come back to later, so you can not start from scratch. Let's start off with just a generic parabola, okay? Y equals x squared. If you go into the settings up top, you can change what you're looking at. You can get rid of the grid if you want. You can get rid of the axis numbers. You can add in arrows, all that stuff depending on what you need. You can alter how wide the X or Y axis is. If you're blind, you can, and you're using a touchscreen, you can put on Braille mode. I don't really know if that works, but yeah, there's a Braille mode for some reason. Okay, also if you're using a touchscreen and you want to zoom in, you can zoom in by, zooming in like you were on a phone. And if you zoom in on a specific axis by squeezing or, not squeezing it, you can just change the X or just change the Y, which is good fun. Okay, let's look at how we make some sliders, because that's how you can create some really cool shapes. I'm going to put a generic letter in front of my x squared, call it A, and then maybe like a plus C on the end. Okay, options to add sliders, we want to do that. Now we can see what happens when we change the coefficient of the x squared. We can make whatever shape we want, and we can change the vertical position. Okay, so sliders are a good way to easily move around your equation, so you can get in whatever shape and position you need for whatever design you are making. If you only want a part of your graph, not the whole thing, so let's say for this parabola, I'm trying to make a shape and I only want to go from maybe here to here, -3 to 3. The way you do that is with these curly braces, okay? This is how you change the domain or range of your design. Let's say I only want x values between -3 and 3. I'll just go -3 is less than x is less than 3. So now I only have the domain of the function between -3 and 3. And maybe I only want the y values above 2. I can also add in y is greater than 2, and then you just have that weird little part there. I don't know why you would need that, but it's still technically part of a parabola. Okay, so that's restrictions. If you want to make some regions to have some colorful areas or shapes, instead of using an equality like an equation, you can use an inequality like less than or greater than. Okay, that's going to shade part of your axis depending on where you want the colors. If you make it a greater than or equal to, you'll include the line. If it's just a greater than, it's a dotted line, of course. If you want to change the color of your areas, you can just click and hold this and it chooses the color for you. You can change the fill and all that good stuff. You can get rid of the boundary if you need to, if you just want to have the colored part, all that good stuff. If that was an equals to and it's just a line, you can also change what the line on. You can change the color of the line, you can change the thickness of the line, you can change the dottedness of the line, lots of different variabilities if you click and hold on this button here. Okay, so let's just go back to regular red. Okay, what else are we going to talk about? Okay, so for the designs in the task that my class are doing, you need to know how to draw a quadratic function, as we just saw. You could draw also a linear function, like x plus something. Again, we'll put things here to make sliders, and then we can change the gradient of our line. We can change the position of our line very easily. So we got a linear function. We could also have a nice generic cubic function. A good way to do this is say y equals something, and then do 3 brackets with sliders a, b, and c. So we have 3 x's, which is going to give us a cubic curve. Add some sliders, and now k changes the slope of the line. B and C and A are going to be your x-intercept, and you can make whatever shape you want. If you want to turn it upside down, you're going to make the k value negative out the front, and then wriggling around, whatever you want to do. If you want to get real funky, you can also animate by pressing play here, and then it just cycles through values and you get this cool dancing line. I don't know why you would want to do that, but I think it looks cool. So there it is. Okay, we've got a cubic. We've also got a hyperbola graph, which is when the x, your independent variable, is on the bottom of a fraction, like y equals k over x. Looks like this. Okay, if you want to change the value of k, it changes the steepness or sharpness of the line. If you want to move it around, you can put in more sliders, A and a B, perhaps. Add them all in and then move it around wherever you want it to be. Okay. If we only wanted the right hand side, we could bring it back to the center by making a 0, which is easier said than done. Yeah, like that. Cool. And now we only want the right hand side, so that's all right. I can just go, I only want X to be greater than 0, and then we only get the right hand side. Okay, so restricting domains is a good way to get part of the graph that you need for your design rather than the entire thing, and gives you more flexibility with your design. So there is our hyperbola, X on the bottom of the fraction. We're also looking at absolute values, which you can do with any function. So let's get rid of all that. Absolute value, let's just look at a parabola, maybe y equals x squared minus 5. Yeah. Okay, absolute values are the vertical brackets on the top right of your keyboard. If you put them around your function, what happens is that the negative parts of your graph, and by negative I mean the parts below the x-axis, they get reflected above and become positive. Okay, this is because absolute values can only output positive values. So any negative values that were in the original function are getting turned positive, and that's why we're going from down here to up here. So you can do an absolute value with any function that you want. You can do a cubic if you are in the mood for it. Yeah, it looks kind of weird. Anyway, lots of variability. This is a good way to get sharp points in your design because the reflections can not be smooth turns like a parabola. They can be sharp bounces, and so you can get some points and some corners if you need them and if you're clever about how you place them. Okay, absolute values, we can also look at some circles. Okay, let's do a generic circle. We've got, so circles have x squareds and y squared. So let's go x minus a squared plus y minus b squared, and let's do radius squared. Okay, adding in sliders. A and B, why does that look weird? Doesn't look, oh, because my axis is weird. It's a bit more normal now. Okay, so A and B are the center coordinates of your circle. So A moves it left and right, B moves it up and down, and then R changes the radius. Okay, if you want to color in the inside of your circle, you just make it less than. If you want to color the outside, you make it greater than. A question that I got on Friday from some students is, how do I make a disc? How do I make a donut? How do I have part of the circle shaded and part of the circle unshaded? Which is actually pretty tricky, but thankfully an ex-student of mine who's now a colleague, McEwen Strawn, helped me figure this out on Friday, so I'm going to put it in this video. Let's go with just a normal one. Let's go x squared plus y squared equals 10. Okay, actually let's go less than 9. So this is the inside of a circle with a radius of 3. Now, I want to include in this a condition, but hang on, I also want x squared plus y squared to be, let's go greater than 4. And there you go. Now with this extra condition on the equation, we have the inside of the circle with a radius of 9, with a radius of 3, sorry, but we have the outside of a circle with a radius of 4, and those two combined give you this donut shape that you could make to form a target or whatever design you're in the mood for, really. So that's how you make a disc. And the last thing I'll show you for the purpose of this assignment is how to shade regions between two functions. So the way you're going to do that is by using function labels. Let's go a parabola, x squared minus 4x. Cool. Now let's chuck in a linear function. Let's go g of x equals, let's go 3x minus 2. No, that looks crap. Let's go half x minus 2. Cool. Now let's say, for some reason, I wanted to shade the region between this line and this curve. This part in here, I want it shaded. Everything else, I don't want shaded. The way we can do that is, we can say f of x is less than y is less than g of x. Okay? This is me saying I want to see the region y that is between function f and function g, which is the part in here. Okay? So using labels of f of x, g of x, whatever letter you want, and then if you put y between those two functions, it will shade the region between those two functions. And you can even get rid of the lines if you need, and then you've just got the cool colored part. And you can get rid of the boundary, and then, yeah, whatever shape you need, you can just trap it between two functions and then get whatever color, whatever shape you want. And it's really useful for making some cool designs. So yeah, go nuts. That's probably the main ones for today. If you have any questions about using Desmos or any other tips for the assignment that I didn't cover in this video, come and see me in class. And to finish off with some inspiration, I'm going to show you some of the best designs that were submitted by students the last time I used this assignment. So we've got some cool designs from last time. Here we go, it's loading. All right, cool. We had some abstract art designs. So it's called create a logo, but you can really create whatever you want. We just want to see some cool stuff used with algebra and equations in Desmos. We had some people go a bit festive and make some Christmas tree logos, which were pretty cool. Butterflies were popular that year. I'll let you decide which one is better, but this face is kind of staring into my soul. We've got some spooky designs. I don't really know what's going on here. Some sort of alien attacking a house. Cool. It's maths. It's beautiful. Ice cream cones, also very big, combining some linear equations and some semicircles and etc. Yeah. And some more food designs. We had a donut shop logo here, which I thought was pretty cool, and this nice little burger shop logo, which is very inventive, combining lots of different curves to create a coherent design, which is the criteria of the assessment. Okay, in fifth place, the fifth best design for this year was submitted by Oliver Bristow. It's this cool hourglass logo inside an eye. I think this was for a security company. I think it's really clever, really well done. Everything's nice and neat. That was number 5. Fourth place is this weird looking dude with a cool hat. This was made by India Rose Cruz. I just think it's a cool design. I like the hat, I like the colors. Yeah, cool. Third place, we've got this funky looking colorful crest, or like a logo for a crest from Emma Keane. Again, good use of colors. I like that the circle encompasses the entire logo and it all fits up and meets really nicely. I think that's really well done, really neat. So that's the kind of stuff that impresses us as the markers. Second place is this really cool picture of some pyramids with the sun peering out behind them from Thomas Gilbert. Again, really elegant, lots of different designs, lots of different use of space and lines, and I just think it's really well done. But in first place, congrats to, this was submitted by Zara Jobson. It's a cool little logo of Sydney Harbour Bridge, and you can't actually see it in the slide, but she even designed it so that the water curve was actually moving. So it was more of like a moving billboard rather than a logo, which we allow because we think it's cool. And yeah, well done, very elegant, very inventive, and a good use of blue, good use of regions, good use of animations. So well done to Zara. Task for you guys is see if you can beat any of these and make it into next year's slideshow. Good luck, thanks for watching, see you in class.